Gold, silver, and bronze medals are awarded to the top finishers in every event in the Olympic Games. This tradition really has been around since the St. Louis Olympic Games in 1904. Now, unfortunately, this year, several athletes have complained about their bronze medals tarnishing or chipping. So while there's talk about having them replaced, we're wondering whether they might have replacements before the Paralympian Games come August the 28th. I am so delighted. I'm joined by Tessa Axum, Director of CNC Fictive, a company that specializes in custom manufacturing processes. And I'd love for Tessa to tell us a little bit about her background and give us some context on these tarnishing metals and tarnishing medals, I should say.
Thank you, Rihanna. So, as Rihanna introduced, I am Tessa Axum, and I've been with Fictive for a little over 2 years now, and I love it here. I'm a mechanical engineer with a background in aerospace design, metallurgy, finishing, CNC machining, welding, brazing, and raw material production. That's a mouthful. And I am here to talk about the Olympic medals, of course. And so, as Rihanna mentioned, one of the concerns for the Olympic medals this year is that some of the bronze medals have been showing signs of discoloration and chipping. And of course, that's not what you want when you're awarded such an honor as an athlete. So, looking into this a little bit further, this year's bronze medal is actually 97% copper, 2.5% zinc, and 0.5% of tin. And I believe is what is actually occurring is copper oxidation. And a nice reference point for this is on pennies that were minted in the United States before 1982. So those actually had about 95% copper and 5% zinc. Newer pennies only have about 2.5% copper. So the older pennies, what we'll see is some brown discoloration and some even that have further discolored and further oxidized, and they turn this green color, and that's actually called patina, copper oxide. So while some news outlets have been reporting that the discoloration and chipping is due to sustainability practices, that's not true. The use of recycled metals to make the metals is not what's causing this. Copper oxidation is actually natural, and copper actually reaches stability when it forms oxides and salts. And so when you have these sweaty athletes wearing these metals, getting salt on them, you're going to get oxidation. So the metals should have been protectively coated. So the first phase in oxidation is actually a red or dull red color, and then it can form a little bit further into a blackish brownish color, and then eventually you get the blue green patina, which could be purple depending on the environment that the copper is exposed to. So to protect this, or to protect the metals from this oxidation, they should have been coated with a clear and protective film to prevent it from occurring. So to kind of provide a barrier between the copper and the atmosphere. And an example of this protective layer would be like Everbright Protect-A-Clear. And perhaps if harassment did apply protective coating and the metals just had some residual contaminants that prevented good adhesion of the coating. So that could be what occurred here. But also the chipping could be due to the fact that the copper oxide powders of polycrystals can be brittle, which further enhances the theory of copper oxidation and kind of explains why they seem to be chipping.
So there should be some kind of corrective action here. What do you think is going to happen now? I mean, how far in advance does the planning of these medals take and the actual process? What can you tell me about that?
So, if I were leading the investigation into what caused this to occur, I would collect a medal and cross section it and mount it and look at it with a scanning electron microscope and maybe do some energy dispersive spectroscopy to determine what actually is the composition of the discolored areas. And so that would lead to the determination of how to reprocess these metals. So perhaps they could be cleaned and recoated with a protective coating, or perhaps they would just decide to melt these down and make new metals. Either way, figuring out what's occurring would help to provide the corrective actions to prevent recurrence, which is really important in continuous improvement and when you have an issue that causes a failure of a part.
Yeah, Tessa, I'm really curious to know, with your background in mind and your own processes at Fictive, walk me through a typical custom design process for a product like a medal. What would happen end to end?
So the process begins with an idea. And for this year's Olympic medals, they had the vision of creating something with Paris in mind, of course. And there's nothing more iconic than the Eiffel Tower. And so they went back to the archives, and this is similar to what a design engineer would do when they're designing a new product. So they would go back and see what had been done before and what references they had to kind of provide insight for the future design. So they decided to take a piece of the Eiffel Tower and then to create ridges coming out from the Eiffel Tower piece in the center. And this is very common for design of something that's very aesthetic. So in this case, the metals don't really have to function. They're not going to be seeing a lot of wear or weight or repeated cycles of use, but they have to look nice. So this process is actually unique because they called on Louis Vuitton, Moet, Hennessy jewelry, and watchmaking designer Chamet. And they actually led the design, which featured some elements from Paris and even the material from the Eiffel Tower itself. And so a design engineer would likely seek the help of an industrial engineer, perhaps even artists in the field to design things that are heavily aesthetic, such as this. And I'm sure that they also had some mechanical engineers and some experts from their jewelry making department weigh in on the manufacturability of the design as well. Which is something that Fictive does really well for our customers. So you can upload a 3D model, and Shamit could have uploaded a version of their design and gotten manufacturability feedback for free with Fictive's AI-driven DFM feedback on the platform.
I would call it a PR nightmare. Maybe it is something maybe it is as uh, maybe it is the fact that the athletes were subjecting their medals to unusual environments. I don't know. Let's give it the benefit of the doubt. But what about the quality control process? How would that would it not have gone through a rigorous testing process?
So I would imagine that each medal that's produced is heavily scrutinized for everything from aesthetics to composition to environmental testing. So what the Olympic Committee sets forth are requirements for the weight of each alloy based off of each metal that's contained in each alloy. And so they actually have to do probably X-ray fluorescence to determine composition or purity in the case of certain metals. And then they would also be doing some visual inspection, probably via the naked eye and microscopes. They would probably weigh the metals, do some process conformity testing. So they would be testing the chemical baths that they would use to clean the metals after production, and then to rinse after cleaning, and then for the clear coating or the sealant. They should be checking those baths. And then hopefully they would do some environmental testing. So that would be destructive or non-destructive testing, like salt spray or even wear resistance in this case, maybe UV light exposure testing. The concern that I have though here is that this year, they actually tasked the design with a jewelry making company, Chamet. So they're known for making like headpieces and very fine jewelry. And so I just have concern if perhaps the design wasn't really considering the environmental conditions. So these are athletes, they're not people going to a ball or, a fancy dinner. So they are going to have salt water on or sweat on them and water and, dirt and stuff. So I just wonder if perhaps they weren't protected enough in the first place. And this is something that they probably wouldn't have noticed if they weren't subjecting these metals to the actual environment during the quality control process.
Yeah. Well, it remains to be seen. Do you think they'll make any modifications on the bronze medals before the 28th?
I would hope so. So I would hope that they would either perhaps re-clean and recoat the metals, or they could, start over with a new batch and just ensure that the new batch is cleaned and coated with a protective coating to prevent oxidation from occurring. And then check the robustness of that coating. So I would probably try out a few different coatings, different chemistries, and expose all of those to a pretty significant salt spray test, and perhaps even some acids as well to see which coating stood up the best. And that's what I would use for the next batch of Olympic bronze medals.
Remains to be seen, and we'll certainly be watching. Tessa, thank you so much for your insights.
Of course. Thank you.